Okay, great. Thank you very much. Thank you for having us here in this event. My name is Sergio Tarazona. I'm here with Gabriel Cuba, and we're both part of Whitestack. And today we're going to talk about the 5G OAI core and all the work we've been done with this solution. Okay. The agenda for today. First, we're going to talk about a little bit about Whitestack, who we are and what we do. Then we're going to talk about why we chose OAI core for this 5G testing that we are doing right now. Then we are going to talk about the previous work we've been doing with OAI. Then the next steps, and finally a demo. Gabriel will be in charge of this part. Okay. So about Whitestack. Whitestack builds carrier-grade supported products based on innovative and efficient open technologies. We're in touch with MNOs, mostly in Latin America, and based on their needs, we look in the ecosystem, open source ecosystem that is currently working in different technologies, and based on that, we choose the best product that we see, and based on that, we build a product. Okay, so for example, we have products based on OpenStack, based on open source Mono, based on Kubernetes, based on Ceph, etc. We take these open technologies and build products. For example, we have some names here: YCloud, YSDN, YTNFB. And when we have these products, we can offer them to the MNOs with the carrier-grade support. This is the stack that we have. We usually can use any kind of server, COTS. Could be based on AMD or Intel processors. And we usually offer these OCP servers based on Open Compute Project. As you know, this is a project created by Facebook at the time. We also provide white boxes for networking based on Broadcom chipsets. But in general, we can work with any kind of servers and switches. On top of that, we have our product called YCloud, based on OpenStack. And together with Ceph and ONOS, Ceph for the storage part and ONOS for the SDN part, we can virtualize all the hardware. And on top of that, we have also one product called WideMist. It's based on Kubernetes. We have also WhiteNFB. It's a telco NFB orchestrator based on open source Mono. We have WhiteMon for all the performance and fault management, and it's based on different tools like Prometheus, Elastic, Grafana, OpenNMS. And we have also a product called Atmosfera for hybrid cloud orchestration, and it's based on ManageIQ. But as I told you before, we saw that many MNOs are interested in 5G, specifically in standalone 5G. So that's one of the reasons that we started to look some product in in the market and start testing just to see if we can make a product, build a product, and help these MNOs to start testing some use cases. So why OAI? First, Whitestack detected that MNOs need to have a non-proprietary 5G standalone core and run solutions also for different use cases. Because currently there's a huge locking related to all the functions that mobile operators using right now. So they're trying to see open technologies to test and implement in production later. And then Whitestack was looking for a 3GPP compliant open source 5G core to start testing and develop a product in a near future. Okay, and we know that OAI has several years of experience working with wireless cellular RAN and core network technologies. Also, OAI has an active community working on delivering new functionalities all the time. For example, they're working on Open RAN and network slicing and continuously adding new features to the core part and also the RAN part. Okay, and finally, Whitestack has had good experiences working with OAI in the past over multi-vendor NFV environments. So there's a high confidence on the joint capabilities to take these solutions to production networks. These are the main reasons that why we chose OpenAirInterface to start testing these 5G standalone core and also RAN solutions. Previous work, what we've been doing so far. In the first step, we choose these 5G core components like AMF, SMF, and NRF, UPF, and some additional components like the third-party GNB SIM and external data network. The deployment method that we used at the beginning was using Docker Compose. And at infrastructure level, we use one VM for 5G core, one VM for GNB SIM, and one VM for external data network. In the second step, 5G cores remain the same. And we change this GNB SIM for OAI RF SIM and new radio UE. We kept the external data network. We kept the Docker Compose deployment method. And the infrastructure was the same. In the third step, what we did was replace this Docker Compose method for Helm charts. And because we have a Kubernetes cluster and we wanted to test in that environment. So at infrastructure level, we replaced this one VM for a cluster with 3 worker nodes. That's why we see 3 VMs for 5G cores in this case. Okay, and in the fourth step, we added additional functions, network functions like UDM, UDR, AUSF. And also we use Hanaspray plugin for the deployment of these Helm charts. So later we will explain why we chose Hanaspray for this implementation. And at infrastructure level, we kept the 3 VMs, the cluster, the Kubernetes cluster, additional VM for RF SIM and new radio UE, and additional virtual machine for external data network. Currently, we're working on the integration of this 5G core with Istio, because we want to have the service mesh of the service-based interface. We want to have observability of this architecture SBA, and also we want to have tracing. So that's why we want to integrate this core with Jagger also. And the next steps that we want to implement in the future. First, we want to test Open RAN using 5G OI core in RAN. Then we want to implement a lab here in South America using a standard GMB, and also using an ORU, Open Radio Unit, for Open RAN testing. Also, we have in mind one proof of concept with one MNO here in Latin America. I think we will start by the July or August of the next year. Okay, about the demo, this is the architecture that we are going to deploy. We have one VM for the RF SIM and new radio UE. We have a cluster, Kubernetes cluster with 3 workers. And we have at control plane level, UDM, UDR, AUSF, NRF, AMF, SMF. And for user plane, we will use the UPF. And we will have additional VM for OAI external data network. The deployment method that we're going to use is Hanaspray. Hanaspray defines an umbrella chart that controls other charts. This allows us to define the order of charts installation, and also allows us to override the values of the charts without modifying them. So we can keep the original OAI charts, considering that each deployment is different. So we don't want to modify the original chart. We just want to add one layer where we can modify considering the specific implementation that we want to achieve. And also we can define the specific order in the chart deployment. For example, we know that NRF should be deployed before AMF. Otherwise, we will have problems with the registration of the network function. So that's why that's another benefit of the Hanaspray. And Hanaspray is just a plugin, easy to install and easy to use. Gabriel we're going to talk about this. And the sequence of the demo. First, we're going to deploy the 5G core using Hanaspray. Then we will check the pod status of each network function. Then we'll start the ORI RF SIM, a new radio UE emulator. Then we will check the logs in 5G core. And finally, we will test using iPerf for uplink and downlink. Okay, so now I'm going to leave you with Gabriel, who's going to perform this demo.
All right, thank you. Let me share my screen.
Okay.
think it's this one. All right, can you see my screen, right?
Yes.
Okay.
Yes,
okay, thank you. So we're going to make a deployment of the OAI 5G core in a Kubernetes cluster, and we want to test it against an RF SIM and an external network, a data network. Both should be outside of the cluster, right? That's what Sergio showed you a few minutes ago. I want to make a reminder. This is the architecture, the topology. So it's important to show you that both the simulator and the external data network are outside the cluster, right? So the cluster is only the 5G core. Okay, so you can anytime you can just replace this simulator with a real, G-Node-B and GUI, and this with the internet, and it should work, right? So, first, I just want to show my setup. We're going to see on these windows the cluster, right? The cluster administration. We can make here some kubectl commands and logs. Here I'm going to show you all the related to the RF SIM, and here all the commands related to the external data network. Okay. So first, our cluster is consists in 4 nodes, I think. Yes. You can make this. So you can see we have 4 nodes, 3 master and worker, and 1 which is only worker. Okay. And we are going to use a specific namespace, which will be OAI, which is already created, and just to make sure that we don't have anything running here. Yes. All right. So we are going to start with a deployment, with each very, very simple. We just have to clone our repo. We make a fork of the federation repository. Okay, but with this, I forgot to remove. Yes. So this repo is basically the same upstream from OAI, but it has our some minor customizations to the charts, and we have here the umbrella chart, which is going to allow us to deploy all the network functions very easily, very quickly. So we are going to check this. Yes, we have here all the charts. I'm sorry. We have all the charts as you will find them in the original Federation repository. And we have this new chart, which is the one we created. And this is an umbrella chart. It means it doesn't really have anything, it won't create any pods, any deployment. It just defines a list of dependencies, which are these subcharts, and it would define some specific values that we want to override from our subcharts, right? This is why this is called in an umbrella chart, right? It has other charts as subcharts. Okay, so once we are here, we can just make a Helm dependency update. Okay, and we're now going to deploy with Hanaspray, like Sergio told you. And we can make sure that Hanaspray is installed by doing this, right? Oh, sorry. Yes, there is. Spray is the plugin. And this plugin is going to allow us to deploy all the subcharts in with a defined order, right? We want the network functions to be deployed or installed in a specific order, right? So just to track the deployment, we're going to make here a watch. Okay, we are going to do a film. We want to use the namespace OAI spray, the umbrella chart, right? And we want to see some logs for this. Yes. Okay, let's see. Yes. So now it's deploying. Just to explain a little bit about Hanaspray, you can see that all the subshards are going to be deployed in a specific order, which is defined by this parameter weight, right? So this is the same order that is specified in the documentation. And as you can see, MySQL is the first one, which it has 0 weight. And the last one is SPGW, right? This order should be respected. And it's not only that the pods are going to be created in the specified order, but Hanaspray is going to wait for the readiness and liveness probes, right? So that's the advantage of using Spray for this case when you need to control the order of deploying. Okay. Okay, so you can see it's going to take a few minutes, but in the meantime, we can check the external data network, right? So we are already running our data network, which is the same one you will find in the Docker deployment guide. Okay, it's a container. We can just get into a bash here. Okay, so it has this IP address, and they should represent an external data network to the core network, right? So we want the UE to be able to connect, to make a ping or to make an iperf to this IP. All right, so we are going to start here an iperf for the uplink. For the uplink case, the data network will be the server, right? Can do something like this. Okay, okay, the core network is already deployed. It took like 2 minutes and yes, a little bit more of 2 minutes. We can see the pods which were created. And I want to explain some things about the pods. You can see that all of them are running, and you can see that they have been created in different nodes from the cluster, right? That's the idea of using Kubernetes, right? You really don't care where they are created in the general case. But we made an exception with SPGW. We wanted to give it a more like bigger node, which is the node 3. And you can see that this is the only network function that is being running on this node 3. MySQL also, but MySQL we really don't care. And the reason for this is that we use labels on the nodes. So if we make this, I'm sorry. So when we show the labels, we created some custom labels. I think this is the name. Yes. So each node too much text here, but I don't know if you can see it. Each node will have a label, right? And we wanted all the nodes to have the control plane label, which is here, no? CNF type control plane. But the node 4, we wanted to have the node 3, we wanted to have the user plane label. So all the more functions will have the control plane, except for the only one, which is the SPGW or the UPF. Right? So that's the way we can control where the different pods will be scheduled, right? Will be created. So if we make a describe, for example, we want to describe the AMF. We want to see it. We can see that the AMF, well, it has been created with the plugin Multus, which allows us to add multiple interfaces to a pod, which by default is only one, but we can add an additional for the radio interface, right? For the S1. Well, we can see here that we are running some containers. First, the TCP dump, which is right now is just sleeping because we don't want to take any capture. We have the AMF, right, with all its environment variables, and we have the Istio proxy, which Sergio talked about. We are making some tests with Istio, so the Istio proxy is running and it's redirecting all the incoming traffic to this proxy to allow us to trace the traffic. Okay, so that's it. Just to finish the idea of the placement of the pods, we defined here some node selectors, right? So that this CNF will be deployed only in a node that has this label, right? So that's how you use the node selectors, and that's how we place the CNF in a specific type of worker node in Kubernetes. Okay, so now let's check the logs. For example, we can check the logs from the AMF with this command and using the label, one of the labels of the AMF pod. We can see that there is no GNB and there is no UE. So we are going to deploy right now the RFC. Okay, so we are going to do that here in this window. We already have prepared the repository, so we just make this Docker compose just to show you that there is nothing running. Okay, we're just going to create the GNB. Yes, you can see here that yes, it's connected now. And we are going to set up the UE now. Yes, we have here the GNB information. We're going to set up the UE. Let's see if we can connect. Yes, it's registered. Okay. So the UE is now attached to the network. And we can make here a bash to the RFCM UE. Okay, so we have the tunnel, the GTP tunnel set up. So we received an IP from the SMF, which is this one. And this allows us to connect to the external data network, right? We still need to apply some commands to get the routing of this container right? So we're going to execute these commands. It's just to add the correct default route, right? Okay, so then the first test is just to make a ping. Yes, it works. So we're just reaching this IP from the external data network. And let's run an IPER. We have the server running already. Let's try the uplink IPER. Okay, which would be this command. All right, this is the server IP. We are binding the IPER to the tunnel IP. Let's try it. Yes, we have some throughput. I tested with a low bandwidth because you know the RF team is very heavy in performance, so we don't want to overload it. The virtual machine is not very big, but we are getting some nice bandwidth, right? It should run for 30 seconds. Yes. Yes, okay, it's finished. We get the bandwidth we want. So now let's try the downlink IPER. We have time, right?
Yes, we have time.
Okay. So now we are going to create an IPER server here in the UE, right? This is the downlink case. Just let me check that. Yes. Yeah, we have this here, the server, and we're going to execute the client here in the external data network. Okay, yes, it's working also. So that's the idea. As you can see, the core network is working as expected. And you can also check that the charts have been installed. I'm sorry. You can list all the charts, and you can see that Hanaspray has installed like if they were deployed separately, right? So you can really uninstall each one in an independent way. You don't need to uninstall everything or to update everything, right? So every subchart can be managed in a separate way, right? And of course, you should use Hanaspray to upgrade, just to make sure you are using the predefined order, right? Okay, so the IPER was successful. I don't know if you have any questions of this demo. So to show you about the ASTO integration, we to this point we managed to at least to capture some traces, right? We can use this using Jagger. We can search for some traces from the control plane. We are still investigating and doing tests, so it's nothing ready, but we can see some traces of the traffic. Okay, so any questions?
Buenos dias. I have a question on the chat. So if the deployment order is not so complicated, so what is the benefit of using Helm?
Okay, the benefit of using Helm is, of course, when you are using Kubernetes, right? If you want to deploy the core network with in separate virtual machines or using Docker, you don't need it. But if you want to use Kubernetes and benefit from the, from the scalability and the, the high availability of a Kubernetes cluster, you should use Helm. I mean, it will make things much easier to deploy things. Otherwise, you would need to create deployments by hand. You would need to create them, and when you need to change something, you need to edit a very big YAML file. So definitely, if you are using Kubernetes, you should use Helm, even for any other kind of applications.
Just because of KA. Thanks.
Yes. Of course, and if you want to know the benefits of using Kubernetes, well, you have the pods, and if you want to, if they are deleted from by someone, it will be recreated on another host. Maybe if you lose some worker nodes, they will be recreated in another available host, right? You don't have to worry about that.
Yeah, I know about KA. Thanks.
Mm-hmm. All right.
Okay, thank you very much, Gabriel and Sergio from Whitestack for.
Right. Thank you.
Thank you.
Okay. So first of all, I would like to thank all my team, Ismael, Remy, Rohan, Tin, Sagar, for setting up the tutorials, the stress tests, the VM, the credential stuff. I was amazing what they did. Okay. Thank you very much for your time. Thank you a lot for participating also to this workshop session. Can you see my screen? Like we did yesterday, we will have a core network challenge for you guys and also for people outside that, okay, but you will have a head start since you had done the labs with us. So the idea is, as you may have seen, currently the subscription management is done with editing the SQL file, whether in Mini or in Basic. And that means that if you want to add a subscriber, we have to shut down and restart again. So that's not nice. So the challenge is to create a solution where you will have a backend interface on the UDR container and a graphical front end where you can have a form to add a subscriber. Don't worry, we will post the requirement on the website, and we post on social media. So the idea is for you guys to provide a solution, and there will be prize, okay, for the winning teams. And you can see on the right, you have the January 10th deadline, and normally we will announce the results on January 4th. And we will use OAI RF simulator to validate the solution. So, or the DNB SIM, it doesn't matter. I mean, we can do both. I mean, it's just a matter. And the idea is that we want the winning team to complete the CI merge request process. So the solution will be included in our solution. And for example, for what the people at Whitestack shown in their environment with a cluster environment, they could have a service to add and remove user later on. Thank you very much for all of you guys to attend this again this session. And
Rafael, can you hear me?
yes, of course.
Because I muted the last time, but still my room doesn't have the picture.
Okay, so we can do the team room now after that. Thank you for reminding me. So I will stop sharing. So if you guys are okay, so Dragoslav and Tolga, sorry, you can wait. We'll talk after the meeting. I will stop sharing. If you are not in Teams room, you can leave. We will start again in 2 hours for the Mosaic 5G if you are registered. Once again, thanks for participating.